Hello and welcome back to Interpreting India. As the world looks hopefully to emerge from the shadow of the coronavirus pandemic, 2022 has so far been defined by another variant of the COVID-19 virus, precarious geopolitical relations, and a rapidly evolving technological landscape. This season, we at Carnegie India are examining many of the challenges and opportunities that India will confront in the coming decade. I'm your host, Konar Bhandari, and this week we're discussing semiconductor policies. Today, semiconductors are ubiquitous. Whether it is the device on which you're streaming this episode, the drive assist or safety features of a car, or aerospace or defense equipment, in the last couple of years, there has been a dearth of semiconductor supply. The semiconductor shortage today can be attributed to supply chain disruptions and several geopolitical factors that had their origins in the early days of COVID-19. Realizing the importance and the potential of semiconductors, countries around the world, including India, have been investing in semiconductor capabilities. In December 2021, the Indian government unveiled a 76,000 crore rupee scheme to boost semiconductor manufacturing, chip design, and assembly and testing and packaging of chips. In this episode of Interpreting India, we'll take a closer look at the Indian government's semiconductor policy and the country's potential in this space. What have governments across the world been doing to strengthen production capability? And how do they compare with India's semiconductor policy of December 2021? What does this ramping up of semiconductor capabilities mean for the rest of the world? To help us navigate some of these questions, we have with us today Mr. G.S. Madhusudan. Mr. G.S. Madhusudan is the CEO and co-founder at Incore Semiconductors, India's first processor IP company. A technology entrepreneur with more than 30 years of experience in creating startups, Mr. Madhusudan is also committed towards engineering diverse software and hardware products, managing R&D labs, and is intricately involved in technology product and strategy development. Mr. Madhusudan, welcome to Interpreting India. Delighted to have you with us.
Thank you for inviting me. Glad to be here.
Let us begin by understanding what are the key factors for India to make a massive push for having a successful semiconductor industry. Now, I've chosen the words here carefully, and the words I've used here are key factors. We'll get to the semiconductor policy a bit later in the course of the podcast, but what would be the factors? So, people usually harp upon things like tech partnerships, infrastructure, talent pool, ease of doing business, supplier ecosystem. But what do you think are the key factors?
Typically, we tend to overcomplicate things, right? Ignore everything that you know about this and concentrate on just on two things. There are only two things that matters. Local consumption of semiconductors and exporting stuff that is manufactured here, right? Both have different issues that stand in the way of India succeeding. Local consumption always depends on the amount of products being consumed in India. 5 years ago, local consumption was insignificant in terms of TVs or mobile phones and all of that. But that is history, right? We consume enormous amount of electronics products, right? So demand for local semiconductors is there. Everything from parts in the mobile phone to TVs to washing machines to fans and all of that. You don't have to go to the high-end, super-duper mobile phone chips and all that, right? Tiny little controllers sitting in the fans and all of that. So we need to understand where the local demand is, especially in terms of volume, and figure out what will it take to create local products. That is one. The second is export. We keep talking about fabs. But electronics export is a lot more than just fabs, correct? If you take a typical $10 semiconductor, the fab cost is probably $2 max, thereabouts, depending on how complex it is. The rest of it comes in intellectual property, in terms of packaging, in terms of R&D expenses and engineering expenses. So if I were to design chips locally and have local packaging plants which are coming, without having a single fab in the country, I can still capture 80% of the value. If you capture 80% of the value, you're there, right? So you don't need to have a fab thrust to have a thriving local semiconductor industry. Qualcomm, Apple, Broadcom, AMD, all of these are big names in the US. None of them own their own fabs. Yet the products they design are considered American products, in spite of the fact that TSMC in Taiwan probably is a major leading thing, right? So a fab is not a necessary condition to have a thriving local industry. There are a lot of other factors at play. Right? So we kind of need to recognize that. And if you take low-cost semiconductors, semiconductors costing below $20, it is no longer viable to design and manufacture these in the West. Uh, so, and it can only be kind of shifted to India or China, no other country, even Taiwan to some degree, because you also need things like documentation, technical support, field application support, and all of it, right? It requires a lot of manpower also. Semiconductor support is an inherently manpower intensive industry also. It's not just manufacturing, right? It is as much a services industry as manufacturing. India, in fact, is better suited for that than China. So, both in terms of local consumption and in terms of export, we need to recognize what do we consume locally and what can we export, right? Once you decide that these are the three thrust areas, then you do the policy to figure out what is required to ramp up on these. We have kind of got the card backwards. We're looking at fabs and then figuring out what we can do with the fab, right? You should decide what products India can build for the local market and for the export market, and decide what kind of ecosystem we need to create here. We already may have a lot of ecosystem components, right? What is missing and stuff. In that respect, a high-end fab should be a low priority item. In fact, old fabs, 180 nanometer, 300 nanometer, 90 nanometer fabs, small optical fabs, gallium nitride fabs, all of that matters. Most of the world's semiconductor consumption is still what I call ancient technology. So ignore the glamour and focus on the bread and butter. How many of us go around marrying models and stuff? I mean, we all marry run of the people and have happy, successful lives. Same thing applies to semiconductors. I don't know why glamour has to figure so prominently in semiconductors. Semiconductors is boring, solid, hardcore engineering. Glamour has no role to play in it. And the instant you introduce glamour, everything goes for a toss. So it's simple to get an industry here. It's not that difficult. We just need to focus on what we can consume, what we can export, and go about it.
So many things to unpack in that, Mr. Madhusudan. You spoke about exporting it, so I'll just get to this point right now. How would India's trade partnerships in this regard hurt or help or stall success in this particular area? I mean, India is missing from the RCEP. India is not a part of the TPP. How would you possibly position India if it is to export its semiconductors successfully? How would that look like?
See, we keep talking about Atmanirbharta, but before Atmanirbharta, you need Atmavishwas, which is what is lacking. We don't need trade partnerships. We don't need to give a damn about the world. We can ignore most of these things. You create great products here. You can sell those products on the strength of those products. We are a civilizational entity. We are just not a chota-mota country, right? That's what I said. Low-cost semiconductors, below $20, $25. You do these manufactured in volume, you can get the markets. Ultimately, if BMW wants chips, it will buy from the best supplier at the best price, irrespective of whether we have a trade agreement with Germany or not. See, all these trade agreements, partnerships, is a compensation for perceived weakness on our part. I frankly think all trade agreements are a waste of time, right? Focus on building great products. See what the country lacks, the reason why we are lagging, and I have no idea why. We make great cars, right? We can't conceptualize good products and create them because we're used to engineering other people's designs, correct? It's very tough. It's next to impossible to find a good VP of marketing for semiconductors in India. You'll get a great VP of engineering, right? So we need to learn the art of conceptualizing and creating products, finding out market niches and stuff. Once you do that, I'm dead set against RC, especially when it comes to all the trade agreements. The first thing they do is try to impose patents on us. I've been fighting patent battles on behalf of Indian companies in Delhi High Court. So every trade agreement that comes so far is negative for India. So my advice, stay out of all of those agreements. Even WTO for me in the IT segment is a waste of time. Yeah, see, you should have high tariffs and all of that. I agree, correct? You can't have high customs duties, but we kind of go overboard in the sense that we need to have alliances and relationship for us to thrive. But that's just me talking. I prefer to stand on my own two shoes without help from anybody else. India can do the same. I frankly can't understand the need or the rationale for partnerships. It holds us back.
I'll just comment to the second part of your initial statement about, first is, of course, creating demand, which is already there. And the second is exporting stuff which is manufactured in India. What do you say to those people who say that by focusing on the more mature nodes of the semiconductor ecosystem, we are sort of compromising our edge on the strategic tech part of the ecosystem?
What strategic part? I'm an advisor to the Ministry of Defense informally and stuff. I know what strategy we have and stuff. I mean, when it comes to strategic tech, I trust people who actually design semiconductors for a living. There is a decoupling between people's ability to actually design semiconductors and their desire to have a public opinion. There is almost a zero overlap between the two. So when people say things like that, just ignore it. Ask them if how many chips they're designed in their life. If the answer is less than 5, just ignore the opinion. Look, we need to crawl before we can walk and before we can run. Running semiconductor plants needs a huge ecosystem. Things like gases, purified water, high precision cooling. So I've written enough notes. What I said was, look, you start 20 small fabs costing between 300 million to $1.5 billion. Then you will create a whole cadre of fab engineers who know how to run a plant. Once you have that, that will take about 5 to 8 years or so. Slowly you can go on to the bigger nodes. But seriously, okay, I want to do a 7 nanometer plant now. Who's going to give you technology? The PLI scheme has been announced. How many people have volunteered with 7 nanometer, even 12 nanometer technology? No, you'll get 65 and 40 and stuff. Look at the consumption of what is getting consumed in the world, just not in India. Every fan, every air conditioner, every washing machine has what's called the DC motor now, right? For energy efficiency, right? You got these BLDC fans which are coming. One manufacturer I know alone does about 7 lakh fans. He's probably hitting like 1 million fans a month. Each of them requires a processor. A XUV 700 has between 60 to 170 processors. Each mirror has got one tiny little processor running there, right? There's a huge demand of old generation parts that is needed. In fact, I jokingly suggested to Meti that you should penalize somebody if they come with a 7 nanometer or 12 nanometer proposal, right? Please focus on 180, 90, 65, 40, along with gallium nitride for RF and all that. I mean, forget the big semiconductors here. I need power converters for motor starters. You know how many motors we make in the world? India can be one of the leading suppliers of electric motors on the planet, right? Coimbatore, for example, is a leading motor supplier and stuff, right? That requires power electronics, which are bulk electronics and stuff. That also requires motor controller chips and all of that. There are huge volumes to be had. You're not going to get a 7 nanometer. It's all nice saying we need strategic tech. If somebody can, there are only 3 guys on the planet with 7 nanometer tech. There is Samsung, there is TSMC, there is Intel. As far as I know, in my conversations with all of them over the past month or so, none of them are waiting in a line to hand over the tech to us. So we can keep dreaming, or we can get practical and get fabs running.
So the obvious implication of this, as you mentioned earlier, is also to focus on the more mature nodes. And Mr. Madhusudan, in a conversation I've had with you earlier as well, you've said focusing on the 70 nanometer range, 45 to 70 nanometer range.
Yeah, well, basically 180, 90, 65, and 40. Those are the 4 important nodes in the older nodes.
Okay, so I just want to, take a deep dive into a recent piece of legislation which was covered extensively by the media, which is the passage of the U.S. CHIPS Act just a few days back by the U.S. Congress. So one of the provisions in that essentially forbids the companies who are the beneficiaries of any, funding from the government to expand any facility in China, which is basically below 28 nanometers. But it allows them at the same time, significantly, what it allows them is to sort of, continue expanding production in the above 28 nanometer range. Does this make India's task more tougher? Now, there was this belief earlier that this decoupling of the tech ecosystems would essentially benefit India. But given that the legislation essentially says that no, China will be a location where these enterprises can indeed pursue the manufacturing of more mature nodes. Does this make the competition for India more stiff?
It does. See, this is what I'm saying, right? If you've got a thriving local industry, you can afford to ignore all of this. When it comes to foreign policy, the Chinese government actually invites me every year for a keynote address. I don't know why, but they call me, I go there, they treat me very nicely and stuff. I've been dealing with China for more than 2 decades and stuff. Lots of friends over there, but mostly Taiwanese Americans, mainland Chinese. I don't know too many, but we know the industry there pretty well because I'm in this sector, right? But even after 2.5 decades, I can't figure them out. My standard policy with China is just ignore it. Just if you got a map in your thing, just like remove it from the map, and it's not positive or negative. I'm not being negative about China and stuff, right? Just pretend it doesn't exist and do your own thing. And stop getting worried about what the American policies or the German policies or the Taiwanese policies, the Japanese policies. We are 1.4 billion people. With the right amount of local consumption, we can call the shots. We should look at what is pragmatic and focus on that. China simply doesn't figure in our radar. We don't even think about it. Can we export to China? Probably not. They have a local thriving industry. There's nothing much we can do over there. But engagement with China can happen only if the Chinese want to engage us, right? It's always been one-sided. They need to respect us. If and when they respect us, probably take another 500,000 years or so, then we can engage with them. But in the interim, like in the next 20, 30 years, we should focus on the local market. 80% local market, 20, 30% export. I tell you, semiconductors, when you actually sell, just go to, see, when you buy chips, especially low-end chips that you put in fans, motors, and all of that, invariably you go to NXP, which is ex Philips, Motorola, or to Texas Instruments. Why? Excellent data sheets, good manuals, proper documentation, good field application support. You write to them, they'll give you samples, easy parts availability, right? The fact that the product is world class is almost secondary. It's the people based. So semiconductor, when it's customer facing, inherently it's a services opportunity. It's not just a manufacturing opportunity. We miss out on that. And because it's a services opportunity, we can run rings around China. Nobody in their right mind would go buy a chip from China if you want to experiment with it, right? They may be great chips. I'm not downplaying the Chinese, but they're not really known for providing great manuals, providing good 24/7 customer support, having local field application support, offices, and all of that, right? So semiconductors is inherently a customer-facing function. We ignore that aspect of it at our own peril. We think it's just some mass manufacturing thing that you do and magically it sells. No, it doesn't. Sales and support is a major, major part of the semicon industry. And the guys who succeed in the market are the people who get the support and services right. It's our opportunity to blow. India can become the number one supplier of low-cost semiconductors to the world very, very easily if we put a mind to it. It's our battle to lose.
I'll just pick up on that thread. You spoke about how India can sort of complement its, I think, design and fabrication ecosystem with the services component as well. Do you think this has been tackled and addressed in the recent policies of the government? Has there been a focus on sort of augmenting the services ecosystem? I mean, we have the Chips to Startup scheme, which is focusing on training 83,000 people or so. But that's mostly engineering side. There's not much of a focus on the services side. So do you think that has...
There isn't any. In fact, there's no focus on the product side itself, correct? So among the chips that we're doing, one of the things that Incor has done is actually helped bring together all the intellectual property suppliers in India. So when we have our first customer, and the unique thing is it's a simple chip, not state of the art. It's like 150, 200 megahertz processor that anybody can do, right? 20 countries in the world can do it. What is unique about it is that every intellectual property in that chip comes from India. We're not using anything from outside, correct? So the government really needs to have a thrust on how do you create product companies, what's the help they need. We need things like certification labs, we need packaging units and all of that, right? That whole product development life cycle is what is missing. Like I said, in a $10 chip, the fab cost is only $1.50 to $2. The rest of it is what India needs to have. Right? For example, auto qualification. We are one of the world's leading auto manufacturers, right? So I make an automotive chip. How do I qualify it? Reliability, testing. Otherwise, Mahindra or Tata won't buy it, correct? I lack the testing infrastructure to qualify it for automotive. Similarly, other certifications, there are a whole bunch of things that need to happen. So I'm not saying the government's focus is wrong, but there are a lot of other things that need to happen before we can become a viable semiconductor product country. See, we can't just be a low-cost supplier to the world, right? The thrust should be, if you buy a chip on the planet, chances are it comes out of India. Conceptualized, created, manufactured in India with zero support from any place on the planet, except foundries. Easily can happen in the next 5 years. Not a problem at all.
That is quite the contrarian view, Mr. Madhusudan. Given all that we have read in the press about partnerships, and given all that we've read about how you can only succeed in one stage of the ecosystem. If you try to do too many things at the same time, it'll probably not succeed. But I mean, you have clearly laid out, a roadmap here in the sense that you've identified certain things the government can do indeed to set the ball rolling in this front. So yeah, the point is well taken. In an earlier conversation with you, again, you had sort of spoken about, that there needs to be a concrete goal in terms of, a production target or something. Do you want to elaborate more on that?
Yeah, see, I'm a chap who believes in taking a small task first and executing to perfection, correct? So, like I said, you take one thing, you just take a motor controller chip and say an electricity meter chip, right? These things sell in tens of millions every year in India. So the volumes are guaranteed. So I wish the government would say, okay, we'll just take two chips, one that goes into fans and ACs and refrigerators, and one that goes into electricity meters, right? So demand for both of these is guaranteed. I think our demand is 25 crore electricity meters or something like that, right? Huge, on point of sale terminals, right? So we actually made a list of 5 chips. Each chip will probably cost you anywhere from 50 crores to 100 crores to design, manufacture, bring it to production. So you're talking about an overall investment of 500 crores, which is nothing. If you invest this 500 crores, essentially you can start selling something between 20 million to 100 million chips in India, right? Out of these 5 chips, you take 2 and take it through the cycle that I'm talking about and see what is lagging in India, right? You make a success of these 2 chips, then the confidence builds itself, correct? While I'm talking, it's still all talk. India still doesn't produce any chips in volumes, right? To get to the stage where we can trust ourselves, you need to take one chip, take it to production, iron out all the wrinkles, and then you know what parts of the ecosystem are lagging in India. Then you use government schemes to fill the gaps, correct? So we need to do a dry run with one chip, get it to volume, then do the second chip. Once you have done 2 chips, then you multiply, saying we'll do 5 more, right? So you gradually build it, and you start with the lower end of the chain. I think the chips can be cost effective. If they're not, okay, give a 5-10% subsidy or something. So typically, for example, electricity meter chips sell for about 90 cents in the market, right? Which goes into single phase meters. 3-phase meter chips, I think, are $1.20 or something. I'm talking in dollars. So if the Indian chip is, say, 10-15 cents more, that's like 7-8 rupees. That's okay. A meter costs 1,500 rupees or something, right? You can easily say a subsidy of 40 rupees per chip till you get a volume of million. After that, we won't give you subsidies, right? We need to get that. So we need to have a razor sharp focus on saying, okay, by 2025, I will have 2 Indian chips selling a volume of 10 million a piece a year. Very hard, concrete goal. Don't get distracted with anything else. Take the 2 to fruition. And once Indian design chips are being manufactured in millions, then everybody gets confident that we can do other things. Otherwise, we are in this endless talk cycle, right? This is no different from a TV talk show, except the talk show there tends to be a little acerbic. Our semiconductor conversations are more polite, but in terms of lack of any useful information, both are identical. Just keep talking, right? I want to see chips. The government is doing, see, I'm not blaming the government here, right? You can't expect the government to create a semiconductor industry all by itself. The government is giving enough incentive. It's up to the private sector to step up to the plate and see what can be done. It has to be a partnership. It can't be a government does everything. The government does have to play a role. If you look at how the semiconductor industry evolved in all countries, the government, US government, Taiwanese government, Japanese government, played a significant role. But when they started, it was very nascent. So that degree of government support was needed. That's not the case now. But the government can help, I guess, in giving chip mandates. For example, if they say that, okay, for electricity meters, we will favor Indian chips only, then the private sector will take the financial risk. Come on, don't tell me we don't have enough money in the country that we can't take a 70 crore bet on one chip. I mean, if I look at my window in the streets here, I'm probably seeing a 3-4, probably about 7 crores worth of cars. I mean, there's one Maybach parked outside. I think a neighbor has some money. There is one Jaguar. There's one E-Class Mercedes. I think there's an S-Class somewhere over there. And yeah, it adds up, right? So I look out of the window, I see like about 10, 15 crores worth of cars. So there's money available to burn. 70 crores to take a gamble on a single chip, which can sell in volumes.
Right. So do you think that the government's incentive structure is a bit lopsided? Should we be giving more incentives to companies which are focused more on the mature node segment, or should we be?
In terms of the fab policy, I have told Meti, forget about 7 nanometers here, focus on the other ones. I can understand where they are coming from, but don't read too much into it. I'm not a firm believer in too much of government incentives, right? I would rather the government works on creating demand. We need a pull instead of a push, correct? See, if as a private sector guy, I know there is a market for 50 million power meter chips, I will go ahead and make the investment. So there needs to be a bit of a demand pull in terms of mandates and stuff. Discussions are happening. I'm hoping some government policy will come by the end of the year or so.
I think for the larger part of this podcast, you have thus far focused on the fabrication part. Let's move over to the design ecosystem for a bit. And if you can just briefly have your thoughts on the DLI scheme which has come out. I mean, it's been appreciated in various quarters, but there are some concerns that the amount being promised under the scheme is not sufficient enough, and what to do when the money dries up. Will any VC firm come and essentially pick up the tab and basically carry the funding forward? Or, is the money which is being promised under the scheme, is it something which is reimbursed, or is it something which is promised upfront? So, we'll be happy.
I think it's partly the scheme is also being redone or something is what I heard. I mean, we also plan to apply for it, but we're not applied because we just wanted to get a few things right before we applied for it. See, DLI is one component of it. One of the concerns I have, and I've told Meti, is also, how do you... I wish the DLI scheme were a little more focused in terms of, whenever subsidies are given, I'm not an anti-subsidy I'm probably slightly more pro-subsidy, but I prefer focused subsidies. And I would like to have measurable outcomes when it comes to subsidies and grants, right? There is nothing wrong with the subsidy per se, provided you have some goal in mind and you at least achieve 80% of that goal. So what is the incentive for DLI? What is it that you hope? Okay, you spent, I think DLI was some 500 crores or 2 lots of 500 crores, 1,000 crores or whatever. Let's assume 1,000 crores, right? You spent the 1,000 crores. It's not a huge amount of money. It's amount of money that's worthwhile experimenting. You spent that 1,000 crores. How do you measure the success of that spending of the 1,000 crores? What are success metrics? What is it that you want to achieve? Do you want to create intellectual property? You want people creating Ethernet controllers or the components that go into a chip. But we already have IP suppliers in India who are not able to sell. Correct? Or are you looking for people who are creating SoCs? But if somebody creates a chip, how is he going to sell it? Okay, you give him 50 crores and he designs a successful chip. The problem in India is sales and marketing in terms of conceptualizing the part. So I go to Meti and saying, okay, this is my DLI spec. Who checks whether that's a viable product in the market? Meti recognizes that they're actually going, they're taking their own pace on the DLI, which is good. I appreciate the fact they're not rushing through with it in trying to figure out, okay, we spent the money, but obviously somebody is going to ask what happened after spending that money. Meti is very cognizant of that. It's not an easy question to answer. I'm not claiming I have all the answers. My suggestion was have a far more focused DLI scheme, which is, okay, ideally, if I were to advise, I would say have DLI for specific parts. Okay, have a DLI for energy meters. Have DLI for point of sale terminal chips, right? Have DLI for a security chip. There, you can kind of measure the outcome, and more importantly, the output can be used into products. So, I think if DLI has more of a product focus in terms of products can get used both locally and abroad, then the government will get bang for the buck. Otherwise, you'll still get returns, but it'll be more long-term and fuzzy. And if the CAG asks questions saying, hey, you spent those 1,000 crores, what happened? It's a very tough one to answer. I'm not saying CAG is wrong, nor is Meti wrong, right? If you don't have well-defined goals and saying it's a long-term goal, that is fine. That's another way of looking at it, right? But those kind of investments, you don't look at ROI. You basically say, okay, I'll spend 1,000 crores to create an ecosystem. And as long as the ecosystem gets created, you should be happy with it. So there the outcome is measured by number of design engineers out there. right? Whereas a more focused DLI will measure its success by the number of chips that got created. Neither is wrong. But you need to decide what is the outcome you desire by spending that 500 to 1,000 crores. So there's no right or wrong answer. I'm just talking about measuring success metrics.
This brings me to my next question, which is sort of related to this topic of chip design. The export controls initiated a couple of years back from the US side have essentially led to the school of thought in China that we should leapfrog it because there's no way we can possibly catch up and make 7 nanometer chips in the next 5, 6 years. So there's talk about, and Chinese companies indeed have sort of, been quite, dominant in the RISC-V Foundation. I think I was going to get to that point. Do you see the RISC-V?
Yeah, they've been dominant, but I have not seen too many Chinese chips come out yet. And see, forget about RISC-V, right? ARM has been there for donkey's years, correct? ARM actually came in 1985, by the way. ARM started as a BBC contestant, so it's been there for a long time. Now, you have a lot of ARM chips out of China and stuff, but the dominant players are still Western players. I keep saying chips are about the services that you offer after you manufacture the chip. It's about the manuals. It's about the technical support. It's about having a call center which properly answers your design questions. See, you're designing a UPS. You put a chip in there. It's not working as it's supposed to behave as per the data sheet. You got a production deadline. You got customers waiting. You need the help from the manufacturer to sort out the problem, right? So if you're buying a chip, say for 250 rupees from a Western vendor, and the Chinese guy gives you 150, yes, you save 100 rupees. But the UPS is selling for 10,000 bucks. If you hold up production, you lose a lot more. So saving that 50, 80 bucks is not worth it if you don't get good support, correct? So if semiconductors are not this monolithic thing that you put engineers into it, you can leapfrog, right? It's chip design, manufacturing, selling is a culture. It is that culture we need to imbibe from the West, not the technology.
But there are still some benefits, which are heavily touted of the RISC-V architecture. Basically, it uses, for performing similar functions compared to x86 and ARM. It basically uses less memory. It's open source.
Oh no! Please don't buy. We are one of the. When I was at IIT, we are one of the founding members of the consortium. All instruction set architectures are similar. The efficiency comes more from how you architect a chip rather than the ISA. What RISC-V gives is a nice, clean business model where you don't have to pay royalties or there's no control. RISC-V is more about a business model than technology. It is more democratic. So RISC-V is a cultural change and a business change. It is not a technology breakthrough. You really need to get that. So a RISC-V chip will not be more efficient than an ARM chip. They'll all be identical. It will not consume less memory. It will not run faster. It will run at the same speed as the ARM. It will consume the same amount of memory. Give and take a little here and there. The efficiency of the chip comes more in how a chip is architected, which has got nothing to do with the ISA. So just going on to RISC-V will not give you any benefit other than the fact that you don't have to pay royalty, you don't have to sign agreements with ARM and all that. You can do whatever you want. It simply gives you more flexibility. But you need a culture of designing products to leverage that flexibility, correct? So unless we have a culture of conceptualizing and creating products, India can't leverage RISC-V. We'll simply provide cheap manpower to the rest of the world to create RISC-V chips. But the products themselves will be conceptualized and created by somebody else. I don't want that to happen, right? I want the products to come out of India. So ideally, if you want to give incentive, I would say give money to a bunch of IIMs and other MBA institutions. Give a stipend of 2 lakhs a month and start creating product managers in the semiconductor sector. See, suppose, you want to create a chip that will go into mobile phones. You need to figure out, which part of the mobile phone do I target? What price point do I target? There are 4 existing suppliers in the market. How do I leapfrog over them? What is my supply chain going to be? What advantage do I have over the existing suppliers? How do I convince the customers to switch from his chip to my chip? Correct? These are the questions you need to answer if you want to have a thriving local products. Designing the part is the easy portion. Selling it to a customer is a tough one.
So, I mean, so far the conversation is very straightforward. It seems to be that, we don't need fancy fabs. We need more of, a dedication to a particular product segment and sort of have a policy laying out the roadmap for people to participate in that. We do not necessarily need RISC-V. What we need is people who can sort of utilize it better in terms of their engineering talent. And even regarding the engineering talent, it needs to be more holistic with a focus on fundraising and, product management and marketing and all that.
No, we don't need RISC-V. See, RISC-V gives us a business advantage, correct? I'm saying it doesn't give you a technical advantage compared to ARM. It definitely gives India and China a business advantage because you're not beholden to anybody. See, suppose you're doing a particular part, say for a Google Home-like speaker, right? And you come up with an innovation where you add 2 instructions to improve voice recognition quality. That is your intellectual property. So an Indian company building an SoC for a Google Home-type speaker can rapidly innovate without paying royalties or being beholden to somebody else. So RISC-V is very crucial to India's success, but please look at it from the intellectual flexibility and the business flexibility it gives you. Not necessarily a technology or a business technology advantage.
I see. And you also spoke at length earlier in the podcast about, sort of fighting patent battles in the Delhi High Court as well. So is there any correlation with that observation and the fact that RISC-V basically is royalty-free?
RISC is royalty-free. Also, RISC-V companies typically don't assert patents. There is also patent pool kind of stuff that is getting created to help RISC-V companies fight patents. I mean, RISC-V companies do file patents, but they typically use it defensive. Fortunately, all the biggies who used to file patent wars have stopped. Very unusually, Microsoft and Cisco, which used to assert patents and take people to court, have joined forces to create a patent-free video standard, right? Talk about a 180-degree turn. Because they said that, look, if, this is for all the video encoding. They're saying, look, if everybody has to pay patent, it's very tough to watch videos on browsers and stuff, correct? I've written an article in Hindu. I am avowedly anti-patent. Even if you file a patent, it should be defensive. See, patents existed not as a fundamental right, but as a government policy to accelerate innovation. Open source technology and open standards like RISC-V have proven that you don't need to incentivize innovation with patents. Patents are a means to an end. If you can have innovation without patents, why should you give a privilege to a company? Especially in software. I'm talking only in the context of software patents and mathematical algorithm type patents, right? I'm not generalizing in terms of medicines or mechanical and stuff. That's an entirely different field. I'm talking only narrowly about software and software related patents.
I think I'll again harp back to the issue of partnerships. So this is something we had earlier spoken about as well, which is, the issue of prototypes. You had mentioned they're really expensive, to secure. And maybe if there is at all a partnership to begin with, it can probably start with, TSMC or someone in Taiwan supplying us maybe 100 prototypes, and then the Indian ecosystem sort of takes it forward from there. Would you get to?
No, that's not a partnership. That's a business arrangement, right? I mean, if you're going to design 100 chips, the government can block capacity with TSMC and say that, hey, we'll give you guaranteed 100 chips, whether you use it or not, and give me a reduced rate. Fine. Beyond that, why would you think TSMC or Intel or anybody will come to India with the sole purpose of improving the Indian ecosystem? No, I'm not saying they're wrong. They are beholden to their shareholders, right? They have to show a return of equity on their shareholders' investment. It is not their job to create a semiconductor industry in India. That is our job. They will help us. They're excellent companies. They're good technology companies. They're always willing for a good business relationship. But that business relationship has to make sense to them. So we need to say, hey, come do business in India because you benefit this way. It's a capitalist society, right? They are not here for our benefit. They are there for the benefit of their shareholders. Nothing wrong with that. That's how it should be. I'm not criticizing any of them. But we tend to get a little emotional about this. I have no idea why.
I think that this ties in well with the point made earlier also about deep tech and strategic tech. It's good to have it, but then it has to be profitable for the companies which seek to manufacture along those segments as well. So the point is well taken. I think we're reaching the close of our allotted time, but I'll just end with this one question, Mr. Madhusudan. You've already mentioned at the beginning of this podcast that there should be two things, creating an industry which has strong domestic demand and then exporting whatever is produced overseas. But if there's any one overarching lesson, after 30 years in the industry, which you wish to sort of impart to Indian policymakers in the semiconductor ecosystem, or maybe even more than one, as many as you wish, what would be those key lessons?
No, just one. You please figure out how to get Indian companies to create world class products, the entire cycle, right from concept to manufacturing. Everything that you see in the world, Apple phones, Intel's Evo laptops, or LG OLED TVs, or Hyundai EV cars and stuff, they're all about products. The world is about products and brands. And if India needs to succeed, it needs to create world-class products. It can be the lower end of the spectrum. You know what a big business rice is in India? That's as glamorous as commodity as you can get. I know people who make hundreds of crores out of selling rice. There is a family that I knew, which the gentleman fell ill. Unfortunately, he didn't make it. But I think he was in the ICU for 2 years at Apollo. And they were some commodity traders or some kind of figure, but they could afford it. Just trading commodities. There's lots of money at the commodity end of the market. And similarly in semiconductors, it's not only the mobile phone chips and stuff that sell. It's also your little power converter chips. The little chip that go into your power adapter outside. Your 65 watt adapters, 100 watt adapters. Those are big volumes. For every mobile phone that you buy, you probably end up buying 3 adapters, correct? Volume. That's the name of the game in semiconductors.
So I guess the key takeaway, if I can just put this in one particular phrase, it would be, if you build it, they will come. If you build world-class products, they will come.
Yep.
You don't necessarily have to rely on partnerships.
They will come.
Trade, while beneficial in the form of lower tariff barriers, would be welcome. But, I think if you show a proficiency for creating world-class products, the partnerships will follow. And I think on that note, we will end the podcast. Mr. Madhusudan, thank you so much for your time. It was indeed a pleasure to have you over, and we look forward to having further conversations with you down the line as well.
You're welcome.
We'll be back in 2 weeks with a new episode. To make sure you don't miss it, be sure to subscribe on Apple Podcasts, Spotify, Stitcher, or wherever you get your podcasts from. To learn more about our research and team, you can visit us at carnegieindia.org. You can also visit us on social media on Twitter, Facebook, and Instagram. Thank you for listening. See you next time.